All right, we're going to go ahead and start our users group presentation today for August. So, we got a large crowd today, so it's great, and we got a great online audience as well. So we appreciate all of our attendees as always. Got a couple introduction slides real quick, and then I'm going to turn it over to our two guest speakers who came all the way down from Milwaukee for us this week, Amanda Eason and Andy Schaeffler, both commercial engineers, and they'll introduce themselves in a moment. So let's kick it off with just our general overview slides that we always give, right? So again, a reminder that our archive is all of our user group sessions and our supporting documentation and recordings and all are on our automation blog. So just a reminder that content is out there. Upcoming user group events. We have September lined up. It's going to be on modular coding with the Studio 5000 kind of modular programming design and a little bit into the new ACM or Application Code Manager. And then October and November are kind of open right now, but we will fill those very soon. As always, we welcome any suggestions for topics. We're here to help provide the right information to our customers. And then in December, we always, what's become a tradition now is our Best in Show 2, and that's going to be our our Automation Fair review. So of course, Automation Fair is in November, and that leads us to our next slide, which is of course a reminder that, believe it or not, Automation Fair is 3 months away in November. So not only that, is Thanksgiving's 3 months away as well. So the year is quickly flying by on us. Registration is now open. It opened about a week ago. And what our customers, what you may or may not realize, is that since Automation Fair is in Houston this year, and we're part of that territory, we actually have first dibs on the technical sessions. So the first dibs for us is only available for about another week. So if you have not registered yet, take advantage of that and go claim the technical sessions and the hands-on labs that you want before it's open to the rest of the world. And just a quick little slide on what the Automation Fair is, in case you guys have not been to it before. But it's a 2-day event with 140 exhibitors. Again, technical sessions, hands-on labs. It's just like a huge trade show floor of all the stuff. So of course the E300 will be there, all the automation products, all of Rockwell's products, and all the probably a lot of commercial engineering support involved there too, to be actually there at the show. So one place, 2 days, can learn a lot and see a lot. And also we have it on our automation blog and at the Reynolds website as well. But there are some perfect day little perfect day kind of agendas. So if you're really interested in like oil and gas, there's like a kind of a perfect day, right? So if you only could spend 1 day at Automation Fair, not really sure what all to do, there's a lot to do. The little perfect day flyer kind of helps you steer you maybe in the right direction for what technical seminars to attend. So with that, I want to not take any more time away from our guest speakers, so I'm going to quickly switch the screen over to Andy, and they will take it away.
Can everybody hear me okay? Okay. Well, first I'll start and thank you, Wayne, and everybody at Reynolds for giving us the opportunity to come down and talk to you about the E300 overload relay. As Wayne mentioned, my name is Andy Schaeffler, and this is Amanda Eason. We're both commercial engineers. I have responsibilities for the IntelliCenter MCCs. Amanda's more component focused, but together we're going to try to tag team the E300 presentation and hopefully give you a little bit of an overview of both component and MCC integration. So before I start in, quick show of hands, who has used E300? Have you had any applications, any familiarity with it? Okay, so a few in the audience. So for everybody else, I'll give you a quick overview of different hardware, different options that you can select, and then we'll get into some of the Logix integration and MCC topologies. So when we look at the E300, we have a few samples here, both on the DIN rail here and in a 3-component starter version. So we want to look at, there's 3 modules. We got a sensing module, a control module, and a communication module. So this offers the modularity that a lot of users are looking for in terms of customizing what type of I/O they want, what type of sensing modules they want, if they want current only or a little bit more in depth with some voltage and power monitoring. And with the smarts of the overload, everybody's talking about the big data and leveraging that data and what that means for the end user in terms of their applications. We really see a lot of the power come from this diagnostics and how it integrates into our IMC or intelligent motor control portfolios. So as I mentioned, the modularity. If you look at, just hold this up for everybody in the room. I apologize for everybody on the phone, but that one's a little bit better. Thank you. It's made up of 3 different components. You got the sensing module in the back that's either going to be panel mount or hook up to a NEMA contactor, IEC contactor. In the middle portion is where you have the control module. This is the brains of it, and this is where all the I/O points get landed, where the output relays are located. And finally, on top piece of the sandwich, the bread, if you will, you have the communication module, and this is for the dual-port Ethernet. So you do need all 3 of these the components to make up a functional overload relay. So even in a standalone application, you still need the COM module on the front. So getting into the sensing module, which again is this portion in the rear, we have different flavors. There's a current only, there's a current and ground fault current, and then finally there's a current voltage and ground fault current. And with the voltage option, you have, with the current and voltage, you can get power, energy, and bring that into some energy metric software or trend in Logix or whatever you're concerned with. Looking at the 4 current ranges, you see there's kind of broken up into a 0.5 amp all the way up to 200 amps native. So these wide current ranges, 10 to 1, and even with the 0.5 to 30 amp, you have a 60 to 1 range compared to the E3 Plus. There's some other familiarity with E3 Plus in the room, that at a 5 to 1 range. So what this does is it allows you to standardize on fewer part numbers to cover a wider range of motor horsepowers. And then on the side here, I just want to show a few different mounting options. So you have the NEMA contactor up to a size 4, IEC mount, and then a few of the pass-through and more panel mount, but with terminals connected to it. So many different options for mounting. Moving along to the control module, portion in the middle of the sandwich, the meat of it, the brains of it, as I like to call it. This is where you have the different flavors in number of outputs, and it's kind of related to your control voltage. So with the 120 volts and the 240 volt AC control, you have 4 in and 3 out. A little bit different with the 24 volt DC, you have 6 inputs and 3 outputs. So depending on what you're using, if that's not enough for you, we have some different expansion I/O modules that allow you to expand that up to a total of 16 additional inputs and 8 additional digital outputs. And then with some of the I/O and protection, we mentioned the ground fault protection in the sensing module that's done internally. With the ground fault control module, that allows you to hook up a core balance CT and actually get down to 20 milliamps, whereas you're limited to 0.5 amp of ground fault current with the internal detection. And then moving on to probably the most critical portion of gathering the sensing module data and the brains of the control module, it's the communication module. So the dual port Ethernet allows you to bring that data out to a control system, out of the control system into Logix. You can, like I mentioned earlier, trend different values and really customize what you're looking for. So we'll show a few different options of doing that later in the presentation. And then it's worth mentioning, right now we have full release of the Ethernet IP communication module. Near future we'll have a DeviceNet version, which would then help users migrate from the E3 Plus to the E300, still using DeviceNet communications. And then finally a parameter configuration. It won't have any sort of communications on it. It's going to have a series of dip switches and dials to set FLA and different protection features. So I touched briefly on the expansion I/O. So we have two different flavors of the expansion I/O modules. And what this does is it communicates on a CAN-based network that plugs into the control module. So you have your dual port Ethernet up here, RJ45 and RJ25 connector for the CAN-based expansion I/O. You get the digital and analog flavors. So digital, just it sounds discrete inputs and relay outputs. The analog is a little bit more customizable. Anything from a 4 to 20 milliamp signal, 0 to 5 volts DC, what have you. So a lot of RTD inputs or other resistive elements that can power and plug into the expansion I/Os. And then we have a few different versions of our operator station. So the basic control station, and then the diagnostic station with the LCD display. And what that does is it gives you, same control features on there, but the only difference is with the diagnostic station you have some LCD display. You can display different parameters, and then there's some configuration with some 4-way keys to get into different E300 parameters. So we will switch over to Amanda's computer at this point, if you don't mind, Wayne. What we want to show is some of the motor diagnostics. We have a little demo for you, so it won't be just me talking to you, but we have not all smoke and mirrors today. We brought some resistive loads in the form of a hairdryer, so it's going to at least pull some current, no motors in here. What we want to do is kind of just show some different time to trip and some other predictive maintenance features built into the E300. So through the web page, Amanda will, I guess, are we plugged in here? Yeah. Yeah, so you can see, I'm hoping everybody can hear me, there's not too much background information on the phone, but you can start seeing the current values go, they're no longer 0. We got a 1-second refresh rate, so they'll update pretty quickly. We'll show it in terms of percent FLA, so you can see that as it increases. And then, if there's any current imbalance or downfall current, wouldn't fall into here. So if we go to power data, yeah, we can do some of that. So it's showing here 120 for a little bit low, 119 volts. But it brings back a lot of information that can be customizable and brought out of the E300. Eventually it'll trip, but we're yeah, so you can start seeing your percent TCU, which is going to be your thermal data. And then what is really nice here is you have a time to trip. And what this does is it gives you some predictive maintenance. So say that time to trip starts decreasing rapidly. There you go. The trip, overload trip. Okay, so a little bit quieter. I won't have to scream at you, but so not only do you see the overload trip, you see the time to reset. So as that thermal memory or the thermal capacity ticks down, it'll show you when you're able to reset and start the process up again. I guess we're good on that. So we'll trip snapshot too. Thank you. So what the trip snapshot does is it gives you real-time information of what took place when what was happening when that trip occurred. So you see we had about 8.5 amps on L1 and L2. Our TCU is obviously at 100% as you saw the overload trip, and then some voltage parameters. So it just gives you some information of why your motor tripped, what the process was doing at that point. Yeah, and then kind of this top portion here, parameters 27 through 31 gives you a trip history. So it just gives you a historical, it stores the last 5 trips, so it's a historical, and we'll say analysis or running tabs of what trips occurred. All right, so you may have seen these as you walked in, but what is nice about the E300, I guess I'm not going to mess with that, but we'll keep it. So traditionally, 3-piece starter, you see all the red control wiring. Now, this is a nightmare with the E3 Plus because if you needed to replace this, you're unwiring and rewiring all the I/O points, your control circuit, and it just doesn't have a nice clean look. With the E300, what engineering did is they designed this little control module adapter that what it does is it takes the power from the E300, wires it through one of the output relays and back up to the contactor coil, assuming that the coils rotate 180 degrees on the load side. And what this does is basically eliminates all of the red wiring with the removable terminal plugs. It makes replacement a snap. Just unplug these. You keep all your connections the same and just plug it right back in the new overload relay. So a really nice feature if you're a panel with a lot of the 103T starters with the E300 on there. Makes it a little bit easier to troubleshoot and get rid of the old components. And then I will close up before I pass over to Amanda, just kind of showing the flexibility. So there's different, I mentioned there's different ways to mount the overload with different contactors, the IEC and the NEMA contactors. A little bit more European styles, but you can see the flexibility. You can actually mount them horizontally on the DIN rail, so there's no right or wrong way to do it, as long as it's okay electrically. There's a pass-through feature and other DIN rail mounts, so just really what I want to do, and I apologize, wish I had some more samples, but just give you a good overview of what's available. Then I saw a few hands with the E300, and is there any other people that were using the E3 Plus? Familiar with it? Okay, so real quick, I'll leave you with kind of a comparison of the E300 and the E3 Plus. So you see same footprint, same X and Y footprint, so the 45 millimeters wide, the same height on it as well when compared to the panel mount adapter, but the only difference is with the dual port Ethernet, you do add about 11 millimeters of depth to it. So for a lot of application that'll be okay. If the panel's relatively shallow, that would be the only problem that would come into play, but for the most part I haven't heard of any issues with that. So we'll turn it over to Amanda for the okay.
All right, so another nice feature about the E300 is that we've also included DeviceLogix. So if any of you all have used it before, it's a nice addition. Basically what it is that inside of the E300, there's a built-in processor, and so it allows you to create custom programs that run within the E300. So one option, you could even use the E300 as kind of like a standalone control, where you bring your inputs into it, and then you can control your motor through the DeviceLogix program. Another thing that we've used a lot of DeviceLogix for is just if you want to do some type of computing with your analog I/O, you can use it for that method. And so one of the nice things that we've done with version 5 and now in version 6 we can customize it is that we've created what we call operating modes. So there's currently 49 different type of operating modes that will allow you to select how you'd like to use your E300 for control. So for example, you could set it up as just a basic overload, or you could set it up as like a non-reversing starter, reversing starter. You could select how you want to use, if you would like to use one of the operator stations, or just use some local I/O, or even use your Logix controller to control your E300. So that's one of the nice features about it. In version 6 of the E300, we've allowed you to go in and actually customize your DeviceLogix programs. So if you've got some type of special configuration that you want to use, you can easily go in and edit the DeviceLogix. And if you look at the picture here, it looks really similar to like a Studio 5000 application. So you can use ladder logic, or you can also use function block diagram programming for that. Also with DeviceLogix, one thing I did want to touch on too is that a lot of times we see people using it as kind of a backup control. So if at some point you ever lost communication with your PLC, you could use the DeviceLogix to keep your process running, or you could also use it to gracefully shut down your process. So you could just keep the logic running as it is, or put something custom in there to try to shut down. So when we look at the E300, one of the nice features and one of the reasons that we kind of consider it a smart device is because we can easily integrate it into a Logix architecture, similar to some of our drives or soft starter products. So with that, we have obviously the Ethernet connectivity that Andy mentioned. We have the dual port Ethernet COM module on the front. Within Logix, we've got an add-on profile for it, and I'll actually kind of go through a demo of that. But with that add-on profile, it'll allow us to configure our E300, and also it brings in a lot of those controller tags that we can use to create our program. And so it's really nice because they have the proper naming convention on them, and they're very descriptive, so it makes it really easy to kind of figure out what tags you want to use for your Logix program. And then one of the other nice features that we're able to use since we've got this Logix integration is automatic device configuration. Have any of you guys been familiar with that? We have a lot of our products have that feature now. So basically, Andy's going to talk about it a little bit later, but what it does is it allows you to store all of your parameter data within your add-on profile, and then as soon as you establish communication between your PLC and your E300, it'll download all of that parameter and configuration data to your E300. So if you ever have a situation where you need to replace one, that's a really nice feature to have. All right, so I mentioned that we have an add-on profile for the E300. This is just kind of an example of it, and I'll walk through a demo of it. But again, it creates the meaningful tag names, so you're able to get really descriptive information from your E300. You get, all of your analog input data. You get, if you have any additional add-on modules, it'll bring all that tag information in as well. And then it also is supported at a minimum of version 16 of DeviceLogix 5000. So this is just another example of the add-on profile feature. I'd mentioned that we have 49 different operating modes, so you can configure it through the web page that we showed earlier, but another nice thing is that you can also configure it through the add-on profile. So it'll allow you to go in and select, what type of control strategy you want to use, and then how do you want to control it. So with your local or remote I/O, or do you want to do it with the operator station? So it really helps to simplify the configuration process. Again, this is another screen showing some of how we can configure some of our I/O. This is one is showing the hold last state feature, so that if you lose communication, that's another way to keep it running by holding the last state. All right, so I'm going to actually open up my Studio 5000 application. Yep. And so with this, I'll kind of walk you through what the add-on profile looks like. Let's see. There we go. All right. So you should be able to see the add-on profile. So I've added one to my Studio 5000 program. And here you can see what the add-on profile looks like. So if I hit this change button, it'll allow me to go in and look at some of the module configurations. So one of the nice features is this upload feature. It's been particularly useful for our MCC customers. So if you ever got an E300 that's already pre-configured, either from the factory or if you've had someone kind of working on it off-site, what this upload feature will do is before you connect with your controller, you want to hit the upload feature, and it will bring in all the parameter data into your add-on profile and have it stored there for you. And that way you don't ever have to run into a situation where you might accidentally overwrite parameters. So that's one of the really nice features. Here you can show where it shows where you can go in and see what your firmware revision is, what type of control and sensing module you have. And then one of the other nice features is this motor operating mode. And this is where I was showing you where you can go in and set what you'd like for your control strategy to be. You can kind of configure how you'd like your relay outputs to be set as well. And then for those users that are interested in DeviceLogix, this is where you enable the DeviceLogix. So there's an Enable Custom DeviceLogix Programming button. And then if you go into your add-on profile here, we have this DeviceLogix. And this is where you can go and access the DeviceLogix editor. And what this will allow you to do is go in and modify those DeviceLogix programs and download them and run them in your E300. So if we just look at some of the other tabs within our add-on profile, you can see here in like our overload protection. Oops. Let me get back to that window. Oops, let me close out my DeviceLogix editor real quick. All right, so in our overload protection, you can see where you can go in and configure like your trip class, your FLA rating. Andy talked a little bit about some of the protection features. So as far as like your current protection, you can go in and configure what type of jams or trips or whatever type of current sensing protection that you'd like to select, and allow you to go in and enable either the warning or the trip, and then also configure the different settings that you'd like for it to warn you a trip at. So it's a really nice feature that we've got, and a lot of our intelligent products have this add-on profile. I mentioned the controller tags. So if we go into our controller tags here, you can see it'll generate all of our predefined tags for us that are really descriptive and allow us to help aid in our programming. All right. So one of the other features that I wanted to show as well is that with the E300 being a smart device, we've created some add-on instructions and then also some faceplate files. And so what this will allow you to do is with this add-on instruction, it basically allows you to kind of get started running a lot faster. There's already some predefined logic that's there. And then it'll allow us to connect to our HMI applications and pull that data in through our HMI. So we have two different flavors of our faceplates. If any of you all are Plant PAX users, there's a Plant PAX version of the E300 faceplate. And then also we've got just kind of our standard faceplate version here. And I will. So this is probably one that a lot of you have seen before, and it's just kind of our standard faceplate. And it allows us to, from our HMI applications, quickly pull in all of the data from our E300. It takes maybe 10 minutes to configure the faceplate files. And from there, you're able to see your trip and warning information. You can also do like a trip reset. You can also control your outputs from the faceplate as well. So that's one of the nice features. If you want to do a test trip. So Andy's actually doing a test trip for us right now. And as you can see, the faceplate will generate this red alarm bell to let you know that we had a trip. Oh, I must have cleared it. Sorry. Yeah. So, but that's one of the nice features is that we're allowed to pull in that trip data, and then one of the nice features with the faceplates is that'll kind of guide us in how we can troubleshoot that error. Okay. Yeah. Yeah, I must have done something to clear it. That's fine.
Can you test trip it from the faceplate?
I don't believe you can. I think just with the blue test trip button, but you can reset the trips from here.
The faceplate that I've got, I can do a test
so
from the faceplate.
These are the two. So there's a Plant PAX and then the standard. There's also a water wastewater version that a lot of people have taken and kind of modified. And I think that one might have a that you can do a test trip, and also I think it gives you some of the time to trip data and some other like trending screens as well.
So with the Plant PAX version, the faceplates allow you to do a remote trip. So you can set up the remote trip feature and trip it from there, but not necessarily a true test trip.
Yeah. So. All right, so I think we go back to our presentation. So one of the other nice features with the E300 and the add-on profile is that if you've got a version 6 E300 with a firmware version 6.114 or the latest, which is 6.115, there's a new electronic keying feature. So if you've ever had, your add-on profile was at version 3, but then you've got a brand new device that's at version 5, once you try to connect to it with your controller, you'll usually get an error message saying there's an electronic keying mismatch. So if you have a version 6, it'll automatically recognize that E300 even if you have a lower rev in your add-on profile. So that's one of the nice features that prevents you from having to go back and try to downgrade your device, or if you've got 50 E300s in your program, you don't want to have to go in and update the add-on profile for all of them. So that's one of the nice features that we've added that makes it a lot easier for you if you have to replace a device. And then one of the other features that, I don't know if you're going to discuss it later, but the DHCP port persistence with our static switches, what that'll do is makes it a little bit easier. You can set up your E300 for DHCP and it'll assign that IP address to it that the existing one had, and that way all you really have to do is just plug in a new E300. It sets the IP address, downloads all your parameters, and you're up and running again. So for any type of maintenance or repair issues, that's a really nice feature that we've got. And then one of the other things that I wanted to point out too, and Andy mentioned a little bit earlier, was that we have the dual port Ethernet. So for your DLR topologies, it also supports the linear or star topology as well. And then one of the other nice features is we have the supports the SMTP messaging. So one of the things that you can do is you can send email alerts. If you've got a trip, it'll send you an email saying that you have a trip, the time of it, and then you can even identify kind of what area. So that's one of the nice features that we have.
Perfect. So I will leave you with, I kind of want to throw in how this relates to an MCC. So to justify my trip down here, being the Intel Center MCC commercial engineer, I want to kind of show redundancy at an MCC level. So typically when we hear redundancy, Amanda mentioned the DLR, everything's going to be in a ring. When we put this into an MCC, I'll kind of walk you through some of the drawbacks of doing that. So standard, we'll take the MCC sections, and from each switch either in a switch unit or in the wireway, we'll run a linear or star network down from that switch. And what this gives us is just the ability to kind of future-proof yourself. You can change buckets around with no disrupting the network when it's powered down. It's configurable and future-proof. So a lot of network testing has gone into this. Kind of highlighted the 10 switch, one uplink per 10 switch, and the 10 switch being kind of the optimal MCC network. So we always talk about redundancy. Everybody hears redundancy in terms of keeping your process going, fault tolerance for any disconnections or severed Ethernet cables. But when you look at it from a high availability standpoint, we can kind of distinguish what that redundancy looks like. So when I say high availability, I'm not going to read verbatim off of the slides, but what it's looking at is not only getting you the data when you want it, but not sacrificing any of the latency or the things that may get introduced with the redundant applications. So we always talk about serviceability. A lot of the times maintenance or engineering is taking the MCC units, they're moving them around, they're constantly switching them out for different starter versions or different units in there. So we look at it from a serviceability standpoint, we look at it from a network and device configuration standpoint, and finally the fault tolerance standpoint. So when we weigh our standard or linear topology or star topology against those three criteria, the serviceability and network configuration, that's a big green check mark. You're able to move and swap the units around, replace the intelligent motor control devices within that network. Clearly the network and device configuration is there. You're able to see all the devices plugging in anywhere along that network. But with that, the fault tolerance is gone. So if one switch were to go down up here in the wireway, everything down from that switch is lost. So a lot of times customers want to implement a device level ring within their MCC section. So what this does is it hits the fault tolerance, so you got a green check box there, check mark there. However, you sacrifice the serviceability and the network and device configuration, because if you were to pull one unit out, you're okay. The ring still keeps alive, but if you pull two out, then your ring is broken in two spots and you're no longer able to communicate to devices on the ring. And again, with network configuration, you're limited in ring topology to 50 nodes. So you're probably asking what our solution is after I show you the two solutions that fall short. So when we look at a high availability redundant MCC solution with Ethernet IP topologies, we look at the same star or linear network here, but what we do is we connect all the switches in a ring. So it's a switch level ring similar to a device level ring. Again, it has the same benefits of the serviceability, configuration, and provides that fault tolerance. So Amanda touched on the automatic device replacement briefly, and what I want to do is kind of just show you pictorially what that means. So, say it's middle of the night, 3 a.m., really agnostic about time, which just paints a better picture if you say it's in the middle of the night, because nobody wants to be out there, trying to figure out what's going on in the middle of the night. So you have a catastrophic event. Your E300 is lost. And what happens is quickly replace, using the removable terminal blocks, you replace the E300, The Stratix switch sends the IP address down to it with what we call DHCP port persistence, and then your Logix processor, which stores the configuration, sends that information down to the E300. So it looks and feels as if nothing ever happened. So I was kind of show you what goes into the ADC. So it's the field device, it's the Logix controller. This is really the heart of what the ADC is using, is the Logix processor, and then finally the Ethernet IP. So I touched on the DHCP port persistence. One thing that's worth mentioning, we hit on this, we hit on the ADC, taking it one step further with firmware supervisor. What this allows you to do is with some of the new L8 processors and version 30 of Studio 5000, what it does is it'll actually download, downgrade, or upgrade the firmware of the E300. So say you pull an older one off your shelf, replace it in there, the processor will actually send the new firmware to it during the ADC process. So it's IP address, configuration, and firmware. And that concludes our presentation. We'll open up to some question and answers. If anybody needs some better clarification on hardware or Ethernet topologies, we'll likely welcome those.
I do have a question. Say you do need to pull an old E3 from somewhere, and you want to replace it somewhere else. You just have some extra ones, and you need to replace one that failed.
Mm-hmm.
If it's been configured before with a static IP, is there a quick and easy way to wipe out that static IP, default it so that ADC can now do its thing?
There is. So what I would recommend is power it up, take the dials underneath the front cover here, set those to 999 cycle power. That'll put it back into a DHCP mode to accept the new IP address.
Okay, thank you.
You have to be plugged in. You have to be plugged into a Stratix switch for automatic device recovery.
For the ADC, no. That's going to be handled by the processor. So if you just have, I'll go back to, if this was out of the equation, you're still connected over Ethernet to the Logix processor, and that'll download the configuration. What the Stratix switch is nice to do is it automatically sets the IP address for you.
So if I replace one and the IP address was wrong, it wouldn't automatically. I would need the Stratix switch.
In that case, it would not. If the IP address was wrong, then that's when the Stratix switch comes in and sets it correctly for you.
But if I said I replace one, let's say I didn't replace the COM module, just the E300,
Mm-hmm.
then it would recognize that the configuration was different.
It would recognize the configuration data would stay the same because that's going to be housed in the control module. So the COM module, if it had the same IP address, when it establishes that connection with it, it does a kind of a handshake or open messaging, and then it'll sense any configuration mismatch and try to download it. But likely, if you're just replacing the COM module, it wouldn't necessarily detect any changes in configuration.
Well, I'm replacing the device and retaining the COM module.
Oh, okay. Sorry, you're leaving the COM module.
Yeah.
In that case, it would sense the mismatch. Yes, I apologize. Then it would send down that data.
Are multiple trip snapshots maintained in the E300?
No, it just stores it for the last trip that occurred.
Okay, so if it trips and the tech instantly takes and resets it, the engineer has no idea why it tripped.
It would retain the trip snapshot until the next one occurs.
Until the next trip, okay.
At that point, it's overwritten.
Problem we ran into is we configured our E300 and we forgot to change, I think it's the motor control mode to motor overload.
Okay.
And once we configured it and applied it, we realized we didn't change it, so we couldn't change it online. We couldn't do a download because we had 20 other motors running on the controller, so we couldn't do a full download. Did we miss something? Is there a way we can change that? What we did is we had to rename it as a _1 and start over. That's a problem for us.
Yeah, and that, if I'm understanding it correctly, what you're already running online, downloaded the processor, and then found out that the motor control operating mode was incorrect, wasn't set properly.
Yep.
In that case, no, you weren't missing anything. You would have to You either take that offline. I would say inhibit the module, but I think you have to be completely offline to get into the module definition and make those changes.
Yeah, and that's what we did. It inhibited that one, created
Right.
a new _1.
Yeah, that's
And re-up.
really the best way to do it.
Before you can make that change before you apply it. You know.
Correct. Before you dump it into the I/O tree and
Yeah.
make that change permanent, yeah, you have to go into there and
So now we got a couple underscore. You know, we got to clean up.
yeah. The problem with that, there are ways to send a message instruction to the overload, but we run into problems with the Logix processor retaining that configuration. So anytime you make a change that the processor doesn't know about, it's going to constantly send that data back to it, overriding all the changes. So you could inhibit the module, go to the web page, you know, that we showed up earlier, and make the motor control operating mode different. But then as soon as you uninhibit that module, it's going to override it right away. Yep. Yep.
What version of Logix constraints are there?
Yeah, it's tested down to version 16 of RSLogix 5000. With version 6 firmware, which is the latest release of firmware, we're limited to version 20 of Logix or greater, and then version 24 or greater of Studio 5000. Got to be more questions than that.
So if you've got a static switch, you have to plug it in the exact same port it came from, though, right?
That's right. So the port persistence is tied to
go to the shop and plug it in their bench and check it all out, and then go out and hook it up.
I did duplicate switch configuration, I guess.
Right.
But yeah, it has to be plugged right in the same port for DHC.
Yeah, that's going to be a function of the port that it's plugged into, not the end device.
And then, of course, it's configured internal to that switch.
I was noticing that.
Is that muted frame? Phil, ask anybody online has questions to type it in.
Yeah, does anybody online have questions? If you do, go ahead and type it in so we can get them answered. We're also going to have the MCC van outside with the E300 in it, and you'll be demoing that, demonstrating how it works with the Intel.
We can get into the Intel Center software. And see how it looks and feels in there for configuration and monitoring.
We'll give a minute, but if other questions, we'll wrap it up here in a second.
Sure.
All right.
Thanks, Bill.
All right. It's like we don't have any questions online and none in the room, so we're going to go ahead and wrap it up a few minutes early today for our web audience. And again, everybody here in the room is invited to step out in the warehouse, and the demo van is outside. So as always, thanks again for joining, and special thanks to Amanda and Andy for our presentation today. And we'll go ahead and conclude. Thanks.